So now we start statistics. And what we're going to start with is a little activity that we'll do in class to see what you know so far about some things like the mean, the median, the mode, the percentiles, box and whisker plots, histograms, all those great things that we learned so long ago. So that's going to be a fun thing to do in class. But basically, statistics kind of starts with data. It's all about the data that you get. And data could be qualitative, like a description, but we're going to focus on the quantitative data, data that has numbers to it. And there's two types of quantitative data. There's discrete data, and the discrete data is when you have specific values. They're particular values. So maybe some examples are like the number of pets you have, or the outcome when you roll a die, or perhaps your shoe size, or like a list of people's shoe sizes. Those are specific values. Whereas continuous data is when you can take any value in that range. And some examples might be like the mass of an object, let's say, or the time to travel to school, for example. All of those values are continuous values. It could be any value in the range, which is different than discrete, where it's like you can only have 2 or 3 or 4 or 5 pets in your house. And likewise, data needs to be both sufficient and reliable. It's sufficient when the data will support a conclusion, and it's reliable when you can get the same results when you repeat that data collection again and again. So that kind of leads us to a couple questions here. How much data is actually sufficient? Well, the data is sufficient when it can represent our population. And there are statistical measures that you can do that are beyond the scope of this course that will let you take a sample size of your data and extrapolate it to represent the whole population. A lot of big words there, huh? And that's why if you ever watch like election results on a TV, for example, what they'll do is they'll say, after 2% of the people that are reporting, we kind of know who the winner is going to be. They have some predictions that they can go by. So it's sufficient when it represents our population. And now, when is that data unreliable? Well, there's two specific times. One is when the data is missing. And that could happen when you're trying to get a survey done and you ask 100 people by email and you get 21 responses. You not have enough data. It's not possible to record any of that data. That's a good example of when it's unreliable. Or maybe when there's errors with the data. Maybe you hear somebody say, oh, there's like 15 different things, and you write down 50. So if there's an error in the reporting, the data becomes unreliable. And we try to get our data to represent the population. The population is everyone in our group. But most of the time, it's really hard to sample everybody or ask everybody. So we get what's called a representative subset, a sample of the group. So those are things when, if you decide that you want to ask people how much time they spend on homework, if you ask the 20-something kids in our class, okay, you'll get the population of the people that are in our class, but it may not be appropriate to consider the results of our class to be the results of the entire school or the entire grade. So you got to be careful when you talk about your sampling methods. And there's a great investigation in your textbook that's on page 280. We're going to take some time in class and work on it, but maybe what you want to try to do is you try to work through it a little bit. So as you work through that investigation, these are some questions to consider. How easy is it to obtain a sample using the method that person's using? Would it give a sample size big enough? Would it give results that represent all the students in the school? These are things to consider. Like I said, if you haven't done so, page 280, take a work through it. I'll wait for you. All right. So as you take a look at some of those, you hear what each people did. Could you maybe combine some of those to get a better representation of the entire school? These are good questions to bring back to class to lead discussions about. Oh, that would be great. So what you got to be careful for when you take these samples, you take these surveys, is any sampling bias. And that bias occurs when your sample does not represent the members of the population. Or maybe if there's some members that are not as likely to be chosen. Okay, your sample's got to represent your entire population. Otherwise, we bring bias into it. And there's a couple techniques that we can use to make sure that we have that bias, or that we don't have that bias. These are some of our sampling methods. So first of all, a convenience method. Who's most accessible? You ask the people at your table that you sit at during lunch, or the people who are on your bus. Or a simple random method. Maybe what we say is something like, hey, every fifth person walks into the school. We do something like that. So everybody's got an equal chance to be selected. Maybe we do a systematic type of technique where we get like a list of their members, and maybe we choose a starting point and some kind of like a fixed interval perhaps. And then you choose, say, like every 10th person off that list. You follow some kind of a system. A stratified method is when you divide them into some specific groups. So for example, maybe we're going to choose 25 freshmen, 25 sophomores, and then you randomly choose a sample from that group. Or maybe you do what's called a quota method. So the sample size is proportionate to the population. So perhaps you know, for example, that 60% of our student body is female and 40% is male. Maybe what you do is you kind of define it that way. So let's take a minute and go back to that investigation. Now that you know some different types of sampling methods, can you identify which ones the student used? And I'll leave it at that.